Hi everyone! This video shows another example on how to write the electronic configuration of an element in the periodic table. So for instance, in this case, they're asking the configuration of the electronic configuration of phosphorus, which has an atomic number of 15. And this means that phosphorus has 15 protons in the nucleus and 15 electrons outside the nucleus. So first of all, we need to understand how electrons are disposed outside the nucleus. And we know from quantum mechanics that the electrons dispose themselves outside the nucleus by occupying allowed states, which we call subshells, of increasing energy, starting from the lowest energy available subshell. And the lowest energy available subshell is the 1s. The second one is the so-called 2s. Then comes the 2p, then 3s, 3p, 4s, 3d, 4p, and so on, as the diagram states. And we know that subshells S are composed by just one orbital. An orbital is represented in the diagram by one of these square boxes. And one orbital can host up to 2 electrons, one with spin up and one with spin down. Therefore, subshells S can host up to 2 electrons. Subshells P, on the other hand, they are formed by 3 different orbitals, each of which can contain up to 2 electrons, and therefore a subshell P can host up to 6 electrons. Then subshells D are formed by 5 different orbitals, and therefore they can host up to 10 electrons. So let's get started. We know that phosphorus has 15 electrons, so we have 15 electrons that need to be allocated. So we start from the lowest energy case, and this is the 1s, and the first pair of electrons will be allocated, one with spin up and one with spin down, in the 1s subshell. And we write this as 1s2. But we still have 13 electrons left to allocate. The second pair of electrons will go into the second lowest allowed energy state, which is the 2s subshell, and we will write that as 2s2. So we still have 11 electrons to go. We know that the 2p subshell can host up to 6 electrons, so we can allocate 6 electrons in the 3 orbitals, 3 with spin up and 3 with spin down, as indicated. And we write this as 2p6. Okay, so we have still 5 electrons left to complete the process. So the next 2 electrons will go into the next available state, which is the 3s, and one with spin up, one with spin down, and we write this as 3s2. Okay, but we have still 3 electrons left, and here comes the tricky thing. We know that the 3p subshell can host up to 6 electrons. Okay, because it's formed by 3 orbitals, and each of them can host up to 2 electrons. So how are we going to be allocating these 3 remaining electrons in the 3p subshell? Are we going to host 2 electrons, one with spin up and one with spin out, in one of the orbitals, and the third one in another one? Or are we going to do something different? Well, the answer is that when electrons are to be occupying orbitals of equal energy, like the case of this example here, the electrons dispose themselves with the maximum unpaired spins. That's the most favorable energy state. And therefore, the 3 remaining electrons will be allocated as it is shown. One electron will spin up in the 3px orbital of the 3p subshell, the second electron in the 3py orbital in the 3p subshell, and the third electron in the 3p orbital in the 3p subshell. We write this as 3p3 because that means that the 3p subshell contains just 3 electrons out of the 6 that it could host. But please notice that the 3 remaining electrons, they dispose themselves in a way so they have the most or the maximum for the case of maximum unpaired spins. Okay, so we are done. We have completed the process, and the electronic configuration of phosphorus is finally equal to 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so I hope you found this video interesting, and I will see you in class. Ciao!